Kia ora Year 12 and 13. Hope your exam revision's going well. I'm going to do some videos on related rates of change because a lot of you find them still really difficult. And these ones are based on the excellent section in Delta, which is 14.2 in the old edition that you've got at home. So I'm going to adapt some of their questions so I don't get into copyright trouble, but you might recognise them. I'm going to start with some of the easier ones and work my way up to ones near the end. And the idea is after that you should be ready to tackle the harder exam problems. So the first one goes like this. Praveen and Ryan are standing at the same point. They start walking away from each other at right angles and they mark out their paths with chalk. They form two sides of a square. They should be square. They walk at a speed of 50 centimetres per second. Find the rate at which the area of the square is increasing when they are 20 metres from the start. Now you're probably wondering why I read all of that out. That's because when you're doing a related rates problem, you must read every single word of the question very carefully. Reading it once is not usually going to be enough, especially with the harder ones. A few wee things to notice just as we're going through that are going to trip you up. This is their speed, and it's given in centimetres. But later on, when we're working with the area of the square, we're asked to find the rate at which the area is increasing when they're 20 metres from the start. So we might as well get the units consistent right from the start. So I'm going to change this speed to 0.5 metres per second. So let's write down what we know and draw a picture. Often in the exam questions there'll be a diagram drawn to help you, but you should always start with one if there isn't. Okay, so Praveen and Ryan are standing here. Praveen walks this way and Ryan walks this way, and they're walking at right angles. They're going at the same rate. So let the distance walked by P or R be x. All right, so this is going to form a square, and the area is going to be x squared. We've been told that their speed is 50 centimetres per second, so we know that dx by dt is equal to 0.5. We've been asked to find the rate at which the area is increasing. So I'm going to do the next part on the next slide. Okay, so we've got dx by dt is 0.5. We know that a is equal to x squared. And our goal is to find dA by dt when they've been going 20 metres, so when x equals 20. Okay, now we think about the chain rule and what we've already got. Well, dA by dt is going to come about like this. It's going to be dA by dx times dx by dt. Notice the way I wrote that is that I wrote down what I wanted to find, and then I knew that I was going to have two derivatives. The last one has to be one that ends with dt, right? Because I'm looking for a rate of change with time, and we've got one of those. So it's got to be dx by dt. The very first one in the chain has to be dA by d something. And in this case, all I need to do is to think, well, this must be dA by dx. Now, with these problems, many of you are going to be sitting there going, yes, that's really obvious. But when we get to the harder ones, the same thing's going to work. One of the exam questions from last year has got something to do with surface area. And you end up with something here, and something here. If you start with the one that you know from the question over here, sometimes it will trigger a good way to solve the problem with looking at these derivatives back here. In this case, it should be reasonably obvious from the chain rule what we're doing. So, what's dA by dx? Well, it's just 2x. So now we're ready to finish it off. We've got dA by dt is equal to this. Well, dA by dx is just 2x. And dx by dt is 0.5, so the whole thing simplifies back to x. And we're asked to evaluate it at x equals 20 metres. So dA by dt is just 20, and my units will be squared metres per second. Right, so the area is growing at 20 metres squared per second when they've walked 20 metres. Thanks for watching. They'll get a little bit harder from here.